Hello, this is Mrs. Rapaski. This video is about electron diagrams and using orbital diagrams to determine how atoms form ions. This is for Chemistry 1, Chapter 5 on quantum mechanics. In order to determine how an atom forms an ion, we can use its orbital diagram. So first we need to remember how to draw the orbital diagram. So we are going to start with sodium. And sodium is here on the periodic table. Sodium's symbol is Na, and to start our orbital diagram, we write the symbol of the element, and then we put a colon because that makes things neat. When we're doing our orbital diagram, we will start reading from the upper left side of the periodic table, work our way all the way across the row, and then keep going down the rows. The first section that we come to is called 1s. The S section always has one orbital, which we represent with one space. There are two boxes in the 1s section, and we will represent those with two arrows. First an up arrow, second a down arrow. Each arrow represents an electron with its spin. After we use the first two boxes on the first row of the periodic table, we're finished with the first row, so we move to the second row. The first section of the second row is called the 2s section. An S sublevel always has one orbital, so we represent that with a single space. We notice that we're in the third and the fourth boxes of the periodic table, and we will represent those electrons with an up arrow and a down arrow. After we're finished with those, we move across the periodic table, and we find that we're in the 2p section because it says that it's the 2p section. A p section always has three orbitals, and we will represent them with three lines. Sodium is not in the p section of the periodic table, so we will have 6 electrons, 1, 2, 3, 4, 5, 6. Okay, and as we fill those in, we need to follow Hund's rule, which is like a cookie rule, meaning that everybody gets 1 before anybody gets 2. So we fill them in up, up, up. So our first 3 electrons are all going the same way. This is called maximum parallel spin, and each orbital is doing the same thing. Then we fill in our last 3 electrons, and they all do the same thing going down. Then after we're in the 2p section, we go to the next row of the periodic table, and this is where sodium is. It is in the 3s section. An S section always has a single space, a single orbital after it. Since sodium is the first element in this section, we represent its electron, okay, with a 1 up arrow. If we count all of the arrows that we have drawn, we get 11, and this is sodium. Now, as we look at this diagram, we can relate it to the Bohr model of the atom, and notice that here we have the first level, which would be like the first ring in a Bohr model, and then the arrows that have 2s in front of them, they represent the second energy level. And then this 3s up is the third level. Now notice that this electron is all by itself, and it's not very happy. So even though all electrons have the same type of charge, and outside of an atom they might repel each other, inside of an atom they actually like to be paired. So this electron, I'm all by myself, I need a friend. Okay? So sodium, okay, might give that electron away. And if sodium gives that electron away, it's going to have a positive charge, and its electron diagram is going to change a little bit. So if it loses 1 electron, it's going to have a +1 charge. So we write it as Na +1. Okay. Then the electrons will fill in the same way, 1s up, down, doing the same thing we did before. 2s with a space, up, down. and 2p. This section is going to be full, but we have to follow Hund's rule. Treat all the orbitals the same way. Fill in our electrons up, 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 down, down, down. Now, if we look at this ion, okay, we have sodium, and it has 11 protons in the nucleus, and it has, as an atom, it has 3 energy levels. Okay. One with 2 electrons, one with 8 electrons, and one with 1 electron. Okay. As an ion, it loses this outer electron and this energy level completely. Okay. So if another element comes in, okay, such as chlorine, okay, here's a chlorine atom, I'll just draw it simply. Chlorine is looking for an extra electron, okay? If it comes along and it sees the way that a sodium ion's electrons are arranged, it sees 8 electrons on that outer shell, and it thinks, oh, I can't react with that, because when it sees 8 electrons on the second energy level and 2 on the first, that looks just like neon. Okay? And neon is a noble gas. So when sodium becomes an ion, it doesn't become neon, but it is dressed in a disguise just as if it were neon. So when an atom forms an ion, it wants to have 8 electrons on its outermost energy level, which is called the valence shell. 8 electrons is a nice set of electrons for atoms, and that helps to make ions stable. In your notes, you have the example for oxygen, so please do the 1s up-down diagram for an oxygen atom. Look at it and then see what you think oxygen must do to become the oxide ion. After you have tried that, look in the notes key or check with a friend to see how well you did. If you need more assistance, please ask for help from a classmate or for your teacher. Thank you very much for watching.